Okay, so hi there everyone. We're now in our next video in the introduction to statistics. We are done with our um, video in the linear correlation. Now we're here in the simple linear regression analysis right now. So this is still part of our batch of videos and the simple linear correlation and regression. So take note that there are more um, examples of linear regressions, and there also exists a topic in nonlinear regression, but it's beyond the scope of our lesson. So let's have this introduction to linear regression. So simple linear regression analysis is a tool with several important applications. Okay, so it can be a way of testing hypotheses concerning the relationship between two category quantitative numerical variables. It's also a way of estimating the specific nature of such relationship. So if simple linear correlation tells us or answers the problem, um, are they related? Okay, this simple linear regression analysis goes beyond that and asks us how are they related. So for instance, it goes beyond asking, for instance, are water consumption and population related? Um, this is just a simple correlation problem. Correlation problems answer this. How are they related? Okay, so it allows prediction of values. Since we know that how they are related, we can now have this prediction of values of one variable if one of the other one is known or estimated. So the independent variable x, we will call that, and the dependent variable y must be specified. Analysis can only be conducted if the value of the Pearson R, that is the Pearson product moment correlation coefficient, simply as the Pearson R, is significantly different from zero. That is, it's not, it doesn't, it must be as much as possible a high correlation. So either high, high positive or high negative, but it should be significantly different from zero. Through we know this by inferential hypothesis. So simple linear regression analysis, we need to first determine the equation of what we call the regression line. Okay, the regression line is the data's line of best fit, or the best fit line of the data. So imagine this scatter plot here. So in the above scatter plot, it is possible to draw many lines that could be used to represent relationship between the two variables x and y. So this is our x here, the x-axis, and the y here. So there's a lot of lines that we can draw with, but what we want is only the best fit. Okay, the one that represents the the um the scatter plot, the data points we have here. So only one can be considered as the best fit. Okay, and the best fit, what do we mean, sir, when you say best fit? Best fit means that the sum of the squares, okay, the sum of the squares of the vertical distance from each point on the line is at the minimum. Okay, so representing the predicted value. So we will try to consider this kind of graph here. So we have data 1, data 2, data 3, data 4, data 5, 6, and 7. So this is our observed value, and this is our predicted value. And this predicted value um, is the line that best fits all of them. So we have here another line here, another point rather. So we can see that it is the sum of the squares, okay, of the vertical distance from each point of the line. So it should be at the minimum. Okay, it should be at the minimum. Okay, so that's when you say that the line itself is best fit. So we won't be having any problems with the best fit line when it comes to graphing, since we have now computers to aid us in doing so. Okay, so we can use Jamovi or Excel, as simple as Microsoft Excel, for us to determine the line of best fit. So to show you one example, let us consider a classic economic relationship between income and expenditure. So this is per capita. Okay, so we have here the region in the Philippines. So NCR going to ARM. So we have here back in 2009, the average income is given here, and the average expenditure is given here. So this is an average, okay, an average. So what we're going to do is to plot them all, plot this average income. We'll put the average income as our independent variable, and the expenditure will be our dependent variable. So whatever our X is, the income, our expenditure depends on that. So, and then we'll plot that on an XY axis, okay, making use only of the first quadrant, and then we'll see what we can have. In plotting them, we can use again Microsoft Excel or Movie, but maybe I can do that in the next video. I will be giving this right now. So this is our income and expenditure profile by region of 2009. I'm going to show you next video on how to do this by using scatter plot in Excel. So, what are these dots, sir? So, for instance, let's look at in particularly this dot. What is this? The average income is around maybe 70 or 60, and we can see the one which is 70 or 60 is the arm. So, 62 is the X, and the Y is 54. And indeed, it's 54 because it's near 50. So that's how we represent it. And all the other dots here represents these values. How about let's try to find this value one. This another one. So the X value is particularly beyond 200. So the only value here which is beyond 200 is from the NCR. The average expenditure of that people there is very near 200, which answers, which gives us 197, which is true. And then you can check all of these dots came from these table here. So we're going to create that again in the next video. So what can we see? What can we observe in this preceding graph, in this graph over here? So the points fall into nearly a perfect straight line. So if we're going to draw a perfect straight line, of course, my drawing is not a perfect straight line. I'm just going to try. All right. So imagine it's a straight line. Okay. So uh, as you can see, the points fall on a perfectly straight line. So that line, if we're going to make use of some computers and some analysis, we can call this line, the one that best fits them all, the line of best fit. Okay, line of best fit or best fit line. So it has a linear relationship. That is, x and y show a linear trend when graphed using a scatter plot. So we can see it from here. Okay, so furthermore, the trend is upward sloping. Which means as the income increases, the expenditure increases as well. Or expect also when the income increases, the expenditure is to rise as well. So we can hypothesize from this given example here that there is a linear relationship between income and expenditure, and to say it is positive. Again, a positive correlation means that as one increases, the other also increases with it. All right? So that's a positive relationship. Um, Further, we can categorize this given graph there in a moment, okay, into a theoretical model. So we can say that the expenditure is equal to the intercept plus the slope times the income plus some random error, of course. So there will be some errors that is very random. So in symbols, we can write that as this. So we have y as the expenditure is equal to the intercept plus the slope times the income, which is our other variable, our independent variable, and some random error. So we can say from this given theoretical model and also our symbolic model that expenditure depends on the income. Okay, because y is our dependent variable and x is the independent variable, and in a practical sense, we can only spend or have some expenses based on the income that we are gathering. So expenditure depends on income, and also expenditure changes by a constant amount every time income increases by 1,000. So we can also see that on the graph because it's a positive trend. So um, as the income increases by a constant amount, say for instance 1,000 here, expenditure also changes, okay, by a constant amount. Okay, so for instance 1,000, so expenditure also increases by one constant amount since it's a positive correlation. Okay, it's a positive linear correlation, and it's a line. It's a line, right? So if it's a line, it's constant. Okay, it's constant increasing. So that's it for the introduction of the simple linear regression analysis. In the next video, we're going to calculate the regression line this time, and then I'm going to show you the how to do the scatter plot of this first example of ours in Microsoft Excel or maybe in Jamovi before we move on to the calculations. So thank you very much for watching. I hope that you would like and subscribe, and see you soon in the next video. So thank you.